Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's SNYK.io/TSD.
There's a chart towards the end of the report that talks about motivations for improving cloud security. And I love the two views there of engineering and security, which is from an engineering lens, the most important motivation is to improve engineering productivity. And from a security lens, the most important reason is to improve security productivity. So I guess the agreement is that this investment improves the productivity of both teams. Just people are more acutely aware of the pain and the opportunity in their world. Hello, everyone. Welcome back to The Secure Developer. Today, we have a different format episode. I think, as we all know, cloud security is sort of a hot space, and everybody agrees that it's very important. Not everybody agrees about what it is. And there's general consensus, though, is that it is a change. It's a departure from how we've been doing things and an area that is worthy of sort of investment and definitions. At Snyk here, we've been running this annual report, which we call the State of Cloud Security, and we've done a special, so probably the broadest version of that this year along, to try and kind of keep a pulse on how people think about cloud security, why they're doing it, what are the learnings, is it important, and a lot more details inside of that. So we're going to use this episode to just sort of dig into some of the learnings, some of the conversations, talk a little bit about what they mean. And to have that conversation, we have with us Simon Maple, who is Snyk Field CTO, and from past episode. Hi, Simon.
Hey.
And Drew Wright, who's a first-timer on the show here and was the primary author behind this sort of report and the survey. Drew, thanks for coming on to the show.
Thanks. Great to be on.
So with that, I'm going to hand it off to Simon, who's been sort of deeper in the report here and will kind of help us explore what's inside here. So Simon, on to you.
Thank you, Guy. And yeah, as someone who's written a number of reports over many years, I always really enjoy getting deep into the data and sometimes having that hypothesis, which is then backed up by data, and very often also being surprised at many of the results that come out of this data. And I think one of the core things is ultimately where we get this data from. So I guess, Drew, my first question really is, in terms of the report, how did you start getting the data from individuals or from the market? What was your approach there?
Sure. So we commissioned the survey from a company called Propeller. They're one of the market leaders in market research to survey more than 400 cloud engineering and cloud security professionals. And that's both kind of getting a cross-section of the practitioners on the security side. That might be a security architect or cloud security analyst, and up to CISO or VP of cloud security. On the engineering side, we're talking about DevOps engineers, cloud engineers, SREs, et cetera, and head of cloud engineering, those kinds of folks. And then kind of get a spread of organization types. So we wanted to get a sense of what enterprise teams are experiencing and are motivated by, or what their objectives are, versus those at startups, public sector organizations, small to medium-sized businesses, et cetera. And it's spread across, organizations that are using AWS or Microsoft Azure or Google Cloud pretty evenly, and then, a multi-cloud footprint as well. And then finally, we added in kind of the primary use case as sort of a sub-demographic, as you will, to kind of understand, how these teams are using the cloud. That might be that kind of more early traditional use case where we're using the cloud as a platform for running migrated applications from the data center or third-party applications, versus kind of the maybe rising use case that we're seeing more and more, which is using the cloud as a platform for building and running applications that we're building in-house. So that's essentially the world that we surveyed for this report.
And it's a very interesting split, actually, that you mentioned there with applications that are built in-house. They obviously go through very different processes, platforms, workflows to compare to software that we are hosting in the cloud, or maybe legacy apps like you mentioned. Guy, I know you did an amount of work looking at the kind of the differentiators between these and how, we as a company, as well as the market, consider the differences between these, how they need to approach each differently. Why don't you talk us through a little bit about that differentiation?
Yeah, I think it's an interesting world. Cloud is this sort of massive beast. And I think at the beginning, it was sort of small enough that we could talk about this in one go and kind of, it's like it's the cloud. But I think we're sort of distancing from that point in time. And today, there's a lot of ways to slice and dice it, but I think the distinction you alluded to now is an important one. And we've been kind of increasingly talking about this as the separation between the IT cloud and the app cloud. And so the IT cloud might be the part of the cloud in which you primarily host applications you purchased or you outsource or things like that. These are, they're applications that you don't generally have the source code to or like the ability to do anything about them. So you're running them kind of as black boxes. They got delivered or shipped in a slightly more waterfall-y fashion, or maybe just the purchased elements to you. So you don't update them very frequently. They maybe bias a bit more VM than container in them, because they're black boxes. You end up, when you talk about securing them, you end up securing their perimeters, the infrastructure they run on, the network. You maybe need to reverse engineer, something. And like when a problem occurs on them, then, it triggers these IT workflows. You need to engage a vendor, right? Or you need to engage a contractor to make some changes because it's not in-house. But IT is kind of the master of that domain, and, they're able to own it. It's not always the title IT, but it's a centralized group. And then if you contrast that to the other side, which we call the app cloud, that's really more about indeed homegrown applications, and especially true for ones that are sort of deployed in a DevOps or continuous fashion. And because those applications are, they change frequently, there's a shared ownership between the IT side, sort of central, people that own the cloud and the people that are building the apps. You ship them often. And so the versions change all the time. And, they're not black boxes. They're white boxes. It is the source code. So while in the IT cloud world, you might need to default to detect and respond, the app cloud world offers you an opportunity to maybe try and sort of find problems early on and actually prevent them, in the first place. And so you have those. That's just sort of a few of many other differences, right? You might have, blue-green trains and dev and staging. So you have multiple versions of the cloud of the same app deployed, which is less likely to happen in the IT cloud world. There's just these million different views. And so, naturally on the Snyk side, we sort of bias because we sort of think about things from the developer angle. We sort of bias in our products towards sort of the app cloud and its capabilities. But I think it's an interesting distinction in the world as a whole, as we think about sort of practices.
I think it's a really interesting one as well, because obviously, like you mentioned, the difference between white box and black box there is really cool because it changes the workflow so significantly, the amount of interaction that a developer would have going through versus, something which, you're just potentially hosting on a cloud. And it's like you say, you're much more secure in the boundary. Was there anything we saw in the report, Drew, that kind of like highlighted these differences or maybe showed from a security posture point of view, whether one was easier to secure than the other or anything like this?
So it's interesting because there's, at least on the surface, some contradictory data. So what we found is that you're more likely to use like cloud native kinds of patterns, architectures such as containers and serverless if you're in that app cloud model. You're building and running on the cloud, and that increases security complexity. Many respondents said that, going kind of cloud native does make security more complex. That said, those use cases, the teams that are in that app cloud model are experiencing fewer serious cloud security incidents. It's not a huge gap, but it's a meaningful one. So 73% of that app cloud, those app cloud teams experienced at least one serious security incident last year. That's versus 89% of those whose primary use case is hosting migrated applications from the data center. So you have, on one hand, kind of this increased complexity, which might just be this is new stuff. And we have to kind of, it has a different sort of security profile, and we have to kind of figure out how to secure that. And usually that comes with shift left on cloud security, much as teams have been shifting left on application security. More likely you're using infrastructure as code, which provides the opportunity to check the security of your cloud infrastructure pre-deployment. in development in CI/CD, and that's a huge boon too. So I think that the app cloud kind of model just gives you, again, a better opportunity to secure the entire software development lifecycle. In that IT cloud model, where you're kind of hosting third-party applications, you're less likely to be using infrastructure as code. You probably one time kind of set up the infrastructure environment, deployed the application, and then you're just maintaining that long-lived infrastructure over time, which, I think can have some security drawbacks. I think there's a level of ephemerality, immutability in more kind of cloud native patterns that have a security benefit inherent in them.
Yeah, just sort of chime in it's interesting. There's always things get, worse and worse and worse and worse and worse until you realize the situation is sort of untenable and you have to do something about them. So it's interesting whether the complexity has kind of tipped us over to the other balance side, in which, okay, like there's enough complexity here that we don't have the illusion that we can manually manage it. And we sort of revert to infrastructure as code and kind of that world. And, I think there was some interesting intro about infrastructure as code as well, which I'm sure we'll dig into.
Mm-hmm. Absolutely.
Yeah, and some of those numbers, I don't know about you, Guy or Drew, if they surprised you, but some of the numbers that you mentioned just then, Drew, earlier on, about, I think was it 89% for groups that are running in kind of more of the black box style cloud environments, suffered a major incident in the past year. Did that seem high to you, or was that kind of more expected?
It's generally in the more expected range. Having run this report every year, it's in line. So a third of the organization suffered a cloud data breach in the past year. It does. I'd say it's not surprising, but it never doesn't feel a bit alarming.
Yeah.
So, and when you think, it's 80% of all organizations suffered some kind of major security incident. So, we're talking about, again, those cloud data breaches. It could be a serious data leak or an environment intrusion, crypto mining in your account, which, can do more damage than just running up your bill. If you've got, similar to like orphaned infrastructure, if you have infrastructure running in your account that you're generally not aware of, that's a huge security risk. You're not scanning it or monitoring it or patching it, what have you. And we do see breaches occur due to kind of that initial penetration vector of orphaned infrastructure or crypto mining infrastructure, those kinds of things, or even dev account, non-production account infrastructure can be a risk as well. So,
yeah. And the numbers were 33% of people had a cloud data breach in the last year. 27% had an environment intrusion and 23% suffered from crypto mining attacks. So it's kind of a little bit scary to see just in the last year how many. And enterprises, compared to some of the other sized organizations, enterprises seem to fare a little bit better. Any thoughts on why that was the case?
So a little bit of data, a little bit of hypothesis I can throw out there. Enterprises lead the way in infrastructure as code use. And my hypothesis on that is that they tend to plan more. And my experience working with enterprises operating at scale in the cloud, under pretty rigorous compliance and security requirements, they're more often than not now making it mandatory that every net new infrastructure deployment must be deployed using infrastructure as code, and that they have to continue using that infrastructure as code. And that's an important caveat there. You tend to see a lot of infrastructure as code get used as kind of an initial deployment mechanism because it's easy, it's fast. We can take the template that, maybe somebody passed over to us that kind of gets the job done for us. We deploy our infrastructure and then kind of abandon the infrastructure as code. And we'll just use the console that the cloud provider provides us to do any ongoing maintenance or updates. If you do that, you tend to lose any kind of long-term security benefits of using infrastructure as code, as well as others, kind of an operational benefit. But if you continue to use that infrastructure as code, you can continue to make sure that everything that you're doing to your environment, all the changes you're making to your environment are secure. And what we see is, particularly in this app cloud model, the infrastructure is changing constantly. Your application developers are continuing to innovate. They're adding more features. Every time they do that, there are going to need to be changes made to your infrastructure environment. And when you use infrastructure as code alongside the application development teams to make this work well, you always have that security feedback loop happening at the very beginning of the development process. So long story short, I think that really helps explain why enterprises are overall experiencing fewer incidents, is because they are, they're planning more and they're really prioritizing infrastructure as code. If you look at like startups, they tend to kind of just get going building things. Oftentimes that happens in the console. And before too long, you've got an infrastructure environment already running, and it can be pretty challenging to apply infrastructure as code to an environment after the fact.
Right. And looking at the adoption stats from the report, enterprises have adopted infrastructure as code at 55% of enterprises doing that versus only 36% of startups and 34% of public sectors. And one of the most interesting stats here as well in the report for me is, I'll read out the headline here: infrastructure as code security reduces misconfiguration by 70%. Again, very compelling figure, but what does it mean in terms of actually adopting infrastructure as code? You mentioned it allows, obviously, infrastructure as code allows people to actually, work on the infrastructure, work on the cloud spaces as early as they possibly can. So during development, as they're building up their applications. From the point of view of an IAC security, how well do you see that being adopted by developers, by other folks early?
Sure. So 91% of infrastructure as code users are integrating security into their development and CI/CD process. So we'd like to see that obviously be 100%, but 91% is about as close as you can get in a survey. It's almost there, more than 9 out of 10. So what we do see that when infrastructure as code is being used, security is being applied to that infrastructure as code, which is great.
I think, Drew, you said it well around the planning element to it. And I think fundamentally, before you use infrastructure as code, you need to constantly make sure to not slip. So you do a lot of actions, and naturally, sometimes you'll leave the door unlocked. Sometimes you'll leave the window open because you need to constantly remember to sort of look behind you and check and verify. While I think infrastructure as code, it's a plan. You sit down, you invest more time in deciding that, this is the right way to inspect or set up or configure it. So you've made that decision, and now it happens for you. It happens automatically, right? Your car locks itself when you've kind of walked away enough, far enough with the keys, or, and I guess that caused all sorts of other problems. So maybe they stopped doing that. But the intent is, if it's built into it, so it happens every time. And I think that's a big deal. I did find, though, I will say that, we kind of glossed over a bit the sort of the ISC adoption being that much higher in the enterprise. And to me, that was a good, insightful moment. It's a little bit less on security than on tech. But I mean, naturally, you think about cloud native, you think startups lead the way, they are cloud native. They are born in the cloud. They run with those. You think of ISC as a modern, a forward-looking cloud native approach. So at first I was does that make sense? But then when you give it more thought, it does kind of make sense, because it sort of comes back. There's this wave, with sort of infrastructure as code. It's easy to use it to set up, and it's important to use it to scale. But when you're in between, you've already set up and you're now not yet at scale, then it might be cheaper in a tactical fashion to not invest that time in ISC. And it's easy for startups to just kind of forego it and continue. But still, I found that stat on the cloud side itself quite interesting and surprising. I do want to mention that on the security and startups failing there, ISC is a good sort of theory on it. But I think another one that comes to mind is the attacker profile. And this is pure conjecture, I think, here. The report doesn't have data to back or refute this. But I think attacks have changed over the years to go from targeted to statistical. Yes, of course, there's also targeted ones. But, it used to be that if you're an enterprise, if you're large enough, you're a big enough target, and therefore attackers target you. And so you invest in security because you're a big enough target and it's important. And, and that creates a certain, kind of a cycle. While if you were a startup, nobody cared about you. And so nobody would attack you. And so you could get away with sort of, doing less security. But today, especially in the cloud, attackers are, there's a whole range, a whole world of attacks that I'd sort of dare say the vast majority of attacks, out there, which are actually statistical attacks. They take a vulnerability and they seek out, and the report kind of describes that sort of shift, right? It goes from finding an attacker and sort of seeking weaknesses to taking a weakness, taking a vulnerability and seeking targets. And in that case, startups can get caught just as much. And so I think that is an industry shift, right? That might put startups in that sort of, tougher place in the equation.
Yeah, I think that this is something that a lot of people in cloud security are missing, and it's an important one to hit on. We're used to seeing headlines like, company suffers cloud data breach due to misconfigured server. And that headline tends, it's technically true, but it's also missing a huge piece of the story. And it's important for people to understand, not necessarily the specifics of what happened beyond the misconfigured server. Let's say the hacker made off with source code from thousands of repos and, customer data across different product lines and these kinds of things. We can all assume safely that all of that source code, all those repos, all that data did not reside on a single misconfigured server. But security tends to be focused on trying to prevent that misconfigured server from becoming, that server from becoming misconfigured. And you need to do that. But it's this, again, when the attacker gets a foothold in your environment, and that may be because there was a misconfigured resource that the attacker found and exploited to kind of get in the front door. It could be an application vulnerability, such as Log4j, that gives the attacker the access point that they need to get into the infrastructure environment. It could be API keys and source code. There's a whole range of initial penetration vectors that's, certainly important for people to recognize that. But once they're in, they want the API keys associated with that resource that enable the attacker to operate against the cloud control plane, the very control plane that we use as cloud customers to build and configure and manage our environment. Because what that gives the attacker the ability to do is first discover all the knowledge that they need about what's in the environment, where might data be, give me a list of all the S3 buckets. Chances are I might be able to figure out which S3 bucket looks the juiciest and that I want to go after. But then it also gives me the ability to move laterally, ultimately get at that data, an S3 bucket, a database snapshot, these kinds of things, and then very quickly copy that data into a resource in my cloud account. And none of these attacks traverse kind of a TCP/IP network that we would be able to monitor for intrusions or nefarious activity. So these attacks can happen very quickly. And this kind of pattern plays a role in every single major cloud breach we see these days. It's not that we left our S3 bucket wide open to the world and had all of our sensitive data in it and somebody came along and stole it. That still does happen these days, but that used to kind of dominate the cloud breach scenario, 7-8 years ago. Today, it's this control plane compromise kind of attack that we see. The attacker gets in somehow, but once they're in, the cloud customer has inadvertently left them a treasure map of the environment, right, and a bag full of IDs that will enable the attacker to essentially impersonate, official business. And, there's no intrusion detection kind of, defense against this. You can and certainly should be, getting all of your logs and analyzing those from a security perspective. But again, the notion that you can identify and stop these kinds of attacks in progress is a dangerous one to take from a security perspective. And that's why, we emphasize that you need to prevent the conditions in your environment that make these kinds of attacks possible. Yeah. It's really your best defense.
It was a really good highlight in the report there on this type of lateral move. It's like automated lateral movement to kind of traverse and explore the cloud you just arrived in.
One other interesting stat that came out of the report was 49% of organizations find that deployment happens faster as a result of improved cloud security. And I think this is always one where when we think about cloud security, a lot of the time, the reasons why we do it, and actually there's another very interesting stat in terms of the priorities of why developers versus security teams want to improve their cloud security posture. But the reasons we want to improve tend to be maybe more about because we want to improve our security posture, because we want to make it, more secure, harder for people to take data, to breach data. But this stat's really, really showing that it can actually enable our business. It can actually allow us to deploy faster and be more competitive in the market based on our improved cloud security. Talk us through your hypothesis in how improved cloud security can achieve this.
Sure. Yeah. And there's a lot there. So I think, why do organizations go to the cloud? They want to be more competitive, innovate faster, time to market, agility, these kinds of things. And what we find is all the tools and technologies and workflows are there to do that. But security increasingly becomes the rate limiting factor for how fast teams can go in the cloud, how much they can get done, and really from an enterprise perspective, how successful your digital transformation can actually be. Because until you transform how you do cloud security, it's those old security kind of approaches and tooling applied to this new kind of way of doing things just doesn't work. And so you wind up with, cloud engineering teams that are really just bogged down in a lot of manual work involved with security. The security team might be, they're continuously checking the running cloud environment for issues that need to be remediated. When they find those, they create a ticket, they throw it over to the engineering team to figure out and remediate. And a lot of times those remediations are not simple ones. It's not just necessarily, flip a bit on a configuration and we're good to go. Sometimes those remediations would be a breaking change for the application. And so there's a lot of rework involved. And so if you're a cloud engineer or an application developer in the cloud, and you're spending an inordinate amount of time dealing with, the security team, like ringing your phone or hitting you up in Slack or sending you a Jira ticket or what have you, it's frustrating. We found, last year, more than half the teams are investing more than 50 engineering hours a week just dealing with things like remediations of issues that the security teams are finding. So when you see that the number one motivation among cloud engineers to improve how they do cloud security is to keep our environment secure, I think that that's both honest. I think we all want to have a more secure computing environment. But if you dig into that a little bit deeper, I think what you'll find is that they're trying to eliminate a lot of headaches and a lot of frustration because they want to spend more time building and less time dealing with, a bunch of manual tasks. What happens when you give a software engineer a manual task that they have to keep doing over and over? Their instinct is how can I automate this away? How can I prevent these kinds of issues from happening so I don't have to deal with them? Because it's just no fun doing this.
I loved there's a chart towards the end of the report that talked about motivations for improving cloud security. And I loved the two views there of engineering and security, which is from an engineering lens, the most important motivation is to improve engineering productivity. And from a security lens, the most important reason is to improve security productivity. So I guess the agreement is that this investment improves the productivity of both teams. Just people are more acutely aware of the pain and the opportunity in their world.
Absolutely. I mean, you can't field an army of security professionals large enough to deal with this problem. And no security team alone can solve this problem. We talk a lot about the shared responsibility model between the cloud customer and the cloud provider, but within the cloud customer organization, cloud security is a shared responsibility, and it needs to involve the security team, the engineering team, the architects, the application developers, all working together early, and the security team embedding with those teams to really understand the use cases and the architectures and bring their knowledge of what's okay and what isn't from a security perspective to bear in that design and development process so we can avoid a lot of these problems. 77% of organizations are experiencing challenges, which is collaboration and issues related to collaboration. But there's tooling and workflows that can really help solve this. Policy as code being probably the most important one, I think, from a security team perspective as well. that I think security teams probably aren't looking at as closely as they should be.
Just as sort of another fun anecdote is this productivity boost is maybe agreed in different views, but there's another question there, which is the motivation to keep our environment secure, in which, the engineering side said, yeah, that's the most important reason. That's sort of a 5 out of 5. The security team is like, well, keep our environment secure. That's 2 out of 5. That's sort of, so basically, from a security team's perspective, improving security team productivity, which, I guess giving them the benefit of the doubt, probably they think that in turn will kind of help us keep the organization secure. But productivity is the top gain from investing in cloud security. So,
and I think one of the other points on that same graphic actually was the engineering response to faster app and feature delivery, which was actually second lowest from the developer point of view, which really shocked me as well. Because when you think about, we always hear this narrative about how developers, they care about, the next feature and pushing out the next feature, et cetera, et cetera. But to hear that the thing that they want to prioritize in cloud security is the reason they're doing it is to keep the environment secure. It's actually really good. And it also shows developers, like we always say, developers are always trying to do the right thing. It's whether they're enabled to do that right thing, empowered to do that right thing, etc. And one of the things I did love about this report actually was that you did also split, as we've done in, I think, in previous other reports as well, splitting the response between engineering and security, because that also does give a very interesting cultural differentiation. And I think one of those, as we'll talk about ownership going into, like you said, shared responsibility and so forth. One stat here, which really poked me in the eye as I was scrolling through, was who is responsible for cloud security. And the cloud engineering team, or the engineering response, was 42% for cloud engineering team. So I guess almost bringing it upon themselves to say, we want to be responsible for this, or we believe we're responsible for this. However, the security response, and I think this has actually been similar across a number of reports that we've seen, not just in the cloud security, but AppSec and other spaces, and the open source security report, the security team were actually over half less than that. So not only 19% of security folks thought that the cloud engineering team were responsible for security. Is this something which is saying that developers and engineering teams are more wanting to take the security responsibility than the security team are willing to give it to them? Is there a cultural misalignment here with responsibility, do you think? Guy, maybe this is one for you. I know you're always very interested in this whole responsibility shift and ownership.
Yeah, and it's a fascinating. It definitely drew my attention as well. And I think, I guess the kind of the interesting bit, it's always, we do these different sort of surveys and all of that. And it's, I think seeing similar patterns across the different reports and different spaces, does reaffirm maybe sort of a lens on what's happening. And yeah, I think there's definitely sort of a bit of a pull or push. I think there's some trepidation, some fear in the security sense of acknowledging, right, of answering a question like, who's primarily responsible for cloud security, with an answer that isn't security. It's kind of their job. It's kind of what they're paid for. And so, there's some complexity probably in sort of, understanding, and survey questions are never perfect. But I do think there's a shift, there's a transformation happening in the industry. And really, we need security organizations to become platform teams, to become engineering teams. I mean, on this podcast, talking to, every time I raise the question, around skills and sort of hiring into the organization, there's fairly consistent views that security leaders today that are sort of forward thinking, they hire for coding skills, they hire for engineering skills. There's a perception that it's easier to teach security than it is to sort of teach, development and software development to these individuals. And there's a transition in which these teams need to become teams that build the tools, build the platform, build the competencies to enable the developers to actually build things that are secure, whether it's policy as code or whatever it is, that's sort of the methodology. They remain the expert. They remain the escalation point. I think that's a shift that's sort of rocking their world, rocking the security world, maybe even a bit more than the engineering world. The only kind of other comment maybe that I would say here is come back a little bit to that IT cloud, app cloud. And I don't know, Drew, if we have data about this. It's surveys always, whenever you get an answer to a question, you want to ask 5 others. I also feel like because the cloud is so conflated, you say cloud security, and I think to half or to some subset of the people, they would really mostly hear IT cloud. And you say, the other part, the other half would mostly hear app cloud and sort of homegrown applications. And I think that distinction is very different, because if you hear IT cloud when you hear cloud security, then clearly you wouldn't bias cloud engineering ownership cloud engineering only exists probably in the world of sort of app cloud, or not. That's not true. Like cloud engineering has broader, but they probably naturally bias in favor of the app cloud. So I don't know, Drew, if that makes sense or is consistent with other data.
It does, from what I've seen is, ownership aside, cloud security and cloud in compliance kind of gets rolled up into this a lot. These responsibilities and tasks do tend to land on them, whether or not they are officially primarily responsible for cloud security. It's not the security team that's doing the remediations. It's the security team, sending a request over, a ticket over. And so, or if it's a compliance burn down list of things that we need to do to bring our cloud environment into compliance, that's going to fall on the engineering team to get done. And so, when you present tasks and problems to the engineering team, they're going to want to try to figure out better ways to do it. And that's, I think, where we see this discrepancy. The cloud engineers are saying, yeah, we are primarily responsible. We're taking more ownership over this. Again, of course, we all want to be more secure. We want our environment to be more secure, but we need to take more ownership over this because the process is broken. And we know that there's better ways to do it. There's infrastructure as code tools. There's policy as code we can use, these kinds of things to make our lives easier and be more productive, to make it easier to retain and hire, other engineers. If you're an organization and your cloud security process is broken and your cloud engineers are having to spend a lot of time doing this kind of stuff that nobody really likes to do, it actually becomes more challenging to hold on to those engineers or to attract additional engineers when there's other organizations that have they're doing a better job on this front, and they're not going to saddle their engineers with, the compliance hat for 3 months or, those kinds of things. And we find too that cloud engineers are a little bit more optimistic about security over the next year and beyond. So, 55% of cloud engineers think the problem's going to get worse. So we'll just put it out there that, pessimism still kind of rules in the sense of, it's a big problem and the attack surface is complex and the attackers are getting really sophisticated. But the security teams they're more pessimistic about the future than the cloud engineering teams. And I think that that's because engineers are engineering solutions to this problem.
I'm kind of smiling a bit here because I feel, it's the whole kind of builder versus breaker mentality a little bit, that sort of optimism element to it. Engineering is almost naturally optimistic. You're building things, you're sort of creating something that didn't exist before, and you need to believe that it can be created and that it would work. And security is naturally pessimistic. It assumes something is flawed. It sort of assumed there is a problem. And so that world is almost negative by design, not to say that the individuals are negative and there's, it has optimists and has pessimists in it, but there's a certain sort of a selection bias that happens over there, which, I guess I come back a little bit to the platform engineering or the notion of security teams becoming platform teams, because I think that bias is, back to the builder, how do we get out of the cycle?
Yeah,
I think cloud security architect is a role that we are seeing appear more and more at organizations, and is a really critical one. I think, security professionals out there that want to do more in cloud security and advance in cloud security would do well by, looking at architect certifications, learning more about how cloud architecture works, and certainly from a security standpoint, and then go sit with these teams, your cloud platform teams, your DevOps teams, to really understand what they're doing, how they're doing it, the CI/CD process for their cloud infrastructure, their IAC tools. This is going to reap huge dividends. And again, we see not only does infrastructure as code security reduce the rate of misconfiguration by 70%, that means you're not digging the hole deeper continuously over time. You are actually starting to reverse the trend and reduce the amount of noise and tickets and alerts and things that you need to, that need to get remediated. But we're also seeing that teams are 70% more productive when we're doing a good job on infrastructure as code security, and that we're delivering faster as well.
Yeah.
So the bottom line for organizations is pretty huge when you really focus on kind of operationalizing your cloud security process across teams and across the software development lifecycle.
And I think, to wrap up this episode, let's look a little bit to the future. And I see one of the stats here was 58% of developers and security professionals predict increased risk over the next year. And I think that's in part because one of the other stats, 77% of organizations state problems with poor training and collaboration as a major challenge. So if you had unlimited budget, unlimited resources, where would you maybe one place that you might invest heavily to help reduce that risk going forward in future?
So I'd say building on a foundation of policy as code that can be integrated into a lot of different things that your organization is doing is probably the best place to invest. And the reason why I think policy as code is so critical is not only can it be a basis for, first, let's talk about really quick what policy as code is. It's the ability to express compliance policies, security policies in a language that other applications can understand and use to evaluate the correctness of what's being done. And what this means is that our security policies aren't solely written in a human language, which is going to be misinterpreted. And there's going to be confusion about how to apply these policies to whatever work it is that I'm doing. It's very difficult for security teams to ensure that all of the security policies are being followed and that they're being followed consistently. But when you adopt policy as code, you are now able to express these policies in a way where you can vend them out to the rest of the organization, and all these different teams, cloud teams, application teams, can use that policy as code in their work, in their IDE, in their CI/CD pipeline, with their IAC tools, in their cloud environment in a uniform way to ensure that everything is correct at every stage that we're operating. And there's no confusion. There's no differences of interpretation. So it has kind of an aligning factor. Everybody's operating under a single source of truth as to what's allowed and what's not allowed. And if, as policies get updated, we're going to learn new things. We're going to understand new attack vectors and create new policies to address those and immediately be able to, we're just managing our policies in a Git repo like we do, the rest of our code. And so it becomes, this is a way for security teams to scale their effort without having to scale up headcount.
And it's also great to be able to have that as part of, a similar dev space, similar dev flow. It's in a Git repo. It's in a format that devs could easily read and maybe even contribute to as well. So that's a great answer. I think that's a really important step for organizations to take.
And I would, organizations that are looking at, every organization should really be making policy as code a priority. Look at Open Policy Agent. It's an open source policy as code framework. It's part of the Cloud Native Computing Foundation, and it enjoys the support of Fortune 500 companies, and it has a huge ecosystem around it, and it's incredibly flexible. So you can use Open Policy Agent for a wide variety of use cases, including infrastructure as code and cloud security, but Kubernetes and other use cases. So it's really a fantastic project, and I suggest everybody go check it out.
Absolutely. And of course, please do check out the report as well. It's actually, there's a lot of really interesting insights, and it's very, very educational to see how others in the industry are dealing with these challenges as well. Drew, very briefly as well, how can someone, obviously links and things like that will be in the show notes, but how would someone get their hands on this report?
So the report is available at snyk.io. I think it's the resources section. I'll have to double check that. And, there's a landing page there where we give you a considerable amount of overview over what's in the report. And then you can download the report for free. And it really digs into each of those different areas.
Thanks, Drew. And I think like a Google for, state of cloud security report will help you find that as well. And just to emphasize this, you can get it for free. The intent is to, just like the podcast, do some knowledge sharing here. Thanks, Drew, for the great report. Thanks, Simon, for the great moderation here and insights. And, for anyone listening, thanks for tuning in. And, this is, as we experiment with different formats, for different sort of type of information that we can share, and what can we do to sort of help spread the knowledge in the ecosystem and bring that knowledge. We'd love to hear from you. We'd love to hear feedback. So if you like this format of an episode, more discussion, with some sort of an anchor of data, then do let us know on, the Twitter spheres or LinkedIn or whatever. I hope you enjoyed the episode and that you join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.